So we moved to bigger and bigger disks, and this introduces some interesting problems, but let's take a look at how the architecture works. We've got a CPU that's talking in some fashion to a RAID disk controller, and that disk controller is talking to a bunch of disks. Let's say I've got 5 disks that are in use in some sort of RAID 5 configuration or RAID 6 configuration, and a hot spare that's always plugged in. And I want you to just think about what's happening here for a second. And ask the question, what's wrong with this kind of a design? I mean, this is, small business. Lots and lots of systems are built this way. Especially as disks have gotten bigger, it's been easier and easier to justify doing this because people have in their mindset that, RAID will take care of my data loss and I don't have to worry about it. First of all, let's talk about a similar sort of thing. Let's talk about twin-engine airplanes versus single-engine. I mean, you see a single engine, you see a twin-engine airplane, you go, well, the twin-engine airplane must be safer because it's got 2 engines, and if one fails, then it doesn't fall out of the sky. Not quite. Reality works more like this. You have twice as many engine failures in a twin-engine airplane, actually slightly more than twice. So twins are actually more dangerous than single-engine systems because the failures just happen more frequently. So using that kind of knowledge, go back to that diagram and say to yourself, okay, what have we got here? We've got one CPU talking to one RAID controller. First of all, part of the reason why twin-engine airplanes are more dangerous is because there are common pieces in between. There's single points of failure. There's a critical engine that if it fails, things are very bad. So also, after that point, not only can we have the disk controller itself fail, but it can fail in bad ways, like it could corrupt the data across multiple volumes because it's a single point of failure. And also we have 6 disks, which is 6 times the likelihood of the system failing because of a bad disk. Now, if one disk fails, you can recover supposedly, but it takes time and it has to rebuild and it's going to run slower in between. So RAID increases the likelihood of failures at the expense of supposedly protecting your data. So that's part of the picture about this is, lots more disks. Now the other thing is, and that you've got to take into account, is that just data rot happens. What can I say about data rot? Every bit of data that you write to a hard disk has some amount of likelihood of failing over time. I mean, if you save a whole bunch of nice videos of your family wedding, over time these will degrade. So the question is, how often and how much, and what is the recovery time if this degrades? And what can we do about this in a realistic perspective? So knowing that eventually data will degrade, not because the disk system fails, not because the hard drive fails, just because, suddenly this bit of data isn't the same when it reads it the next time. Also, as disks have gotten larger and larger capacity, this rate of data rot has increased because the little magnetic patches that it's writing on each disk have gotten smaller and smaller. So the chances of something like, let's say, a cosmic ray coming through and zapping that spot on your disk and erasing the entire patch or flipping the bits in that patch has increased. So out of this we can actually calculate, and there's a little table in the notes that lists the data loss per year. And if you start looking at different RAID systems in that table, you'll find that the data loss can be quite high. Like 1 in 2.7 is listed in there. Also, the amount of time it takes to rebuild. If you lose a disk, it finds that it's gone, it's bad, it has bad enough data loss that the disk itself catches it and reports an error, and then you go to that spare and try to rebuild it, look at the column in there that lists the amount of time it takes to rebuild. Some of those things are like 5 days and 16 hours. We live in a world that has all these wonderful online applications that we expect to work all the time and never fail and never lose our data. How many of them do you see saying something nice to their users like Gmail? Oh, we had a data loss and we're recovering and we'll be back in 5 days and 16 hours. Now, the other part of this is in that 5 days and 16 hours, you've lost your redundancy, which means that for the duration of that time, you no longer are protected by whatever RAID system you are using. So the limitations of the system are suddenly starting to become much more manifest. You know, in the old dark days when we had 5 megabyte disks and you could rebuild a disk in 6-7 minutes, RAID made a lot of sense to save a bunch of money. Today we need to move on to a different kind of architecture, and we'll talk about that next.